All right. Happy National Tug of War Day. Okay. There wasn't many today because it's Iwo Jima Day. So it's the day that the invasion of Iwo Jima happened in World War II. So there's not really many today. It was either this one or it was National Lash Day. Like eyelash day. Like eyelashes. And I'm like, no. Tug of War Day. So, yeah. Just a couple of reminders from the start. First reminder is tomorrow you're going to have a formative. Okay? It will cover vectors and navigation and yes. Okay? So everything that we've done last week and this week will be on that one. Okay? And then the Pi Day extra credit. Remember, we are not accepting store-bought pies. Okay? Or I shouldn't say we're not accepting it. We'll accept them. We'll eat them. Okay? But you won't get any extra credit points for a store-bought pie. Okay? Okay? Just saying. Okay? And those are due in class the day of March 13th. That's a no exceptions hard deadline day. Okay? All right? So our first warm-up today is this one. So our angle is north 16 degrees west. I need you to find me the bearing angle, the reference angle, and the trig angle. Okay? So north 16 degrees west would be up here, where this angle here is 16 degrees. It's a bad 6, so let's fix that. Okay. So the trig angle then would be from here to there, so that would be 106 degrees. Agree with me on that? Okay. My reference angle would be from the horizontal, so that would be 74 degrees. Yes? And my bearing angle is going to start here and come all the way around to there. And so that is going to be 344 degrees. Agree with me on those three? Yes? Okay. All right. But there will be, tomorrow on your formative, there will be a find me the other three. Here's one of the 4, find me the other 3. Okay? All right? If the one is a reference angle, we will also tell you which quadrant it is in. Okay? All right. So, here's the next scenario. So, the magnitude of vector u is 13. The direction angle for vector u is 95 degrees. The magnitude of vector v is 8, and v's direction angle is 321 degrees. We want to find these different things. And I'm going to show you this using our calculators, because the reason I'm showing you this is we seem to be getting off by just a little bit every single time, because you guys are using the basic calculators, okay, where you can't store a bunch of stuff. Okay? There's a lot of stuff that you need to store on this one, on these type of problems. Okay? So first off, what I'm going to do is I'm going to set up, I'm just moving these all over here. I'm going to set up my vectors. So vector u, hold on, let me even move this over here too. Vector u is going to be 13 cosine of 95 degrees, comma, 13 sine of 95. Oops, I put in parentheses. First time all vectors that I put in parentheses. Usually it happens a lot. Agree with me on that. Okay? So on my calculator now, okay? Come on, calculator. There we go. On my calculator, I need to be in a document in order to do this. Okay? So you need to be in a document, and I need to be in a calculator. Okay? Don't save it if you have to save something. Okay? So the first thing that I'm going to punch in is I'm going to punch in 13 cosine of 95. Making sure that I'm in degrees. Make sure it says DEG up here in the corner. Okay? If it says RAD, scroll your cursor up to that spot and hit the center button on the trackpad. Okay? When I hit enter, okay, for me it switches it over, but I think on yours it should say something along the lines of like this. Yes? Okay? Now, here's what I'm going to do. I'm going to store that because we're going to be using it a lot. So I'm going to store that. Control var tells me I can store it as I've got 26 options down here. I'm going to go with A because it's the first one. Okay, so I'm going to store that as A, and then when I hit enter, now that value, 13 cosine of 95 degrees, I just have to hit A for it. Okay? All right? So that's negative 1.133. And I'm also going to denote on my paper that I stored that on my calculator as A. So then I know. Okay? Then I'm going to do 13 sine of 95. That's going to be 12.951. And again, I'm going to store that, control var. This time I've got to pick a different. Now I've only got 25 choices because I've used A, so I'm going to go with B. $12.951. And I went with B for that one. With me so far? Okay. Now I need to do vector V. Vector V is going to be 8 cosine of 321 degrees, 8 sine of 321 degrees. Eight cosine 321. I'm going to store that as C. Okay. 6.217. Eight sine 321. Negative 5.35. I'm going to store that, I'm guessing, as D. Okay. Again, you could pick any of the letters. You just can't double store something on the same letter. So negative 5.345. Negative 5.345. Oops, I thought there was a 0 in there. 0, 3, 5. And that's going to be D. Okay? So now I have my vector safely stored on my calculator. And when it's stored, I have it written down here to 3 decimal places, but on the calculator, it's got all of them. Okay? It doesn't round on there. It's not rounded. It's what it is. Okay? All right? So now we want to find vector 3u minus 2v. Okay? So on my calculator, what this is going to be is this is going to be 3a minus 2c, comma, 3b minus 2d. With me on that? Because it's 3 times vector u, so that means I got to go 3a in my horizontal and 3b in my vertical, minus 2v, so that would be minus 2c in my horizontal, minus 2d in my vertical. Okay? So let's go here now, 3a minus 2c. And literally I just go 3a minus 2c. And it tells me what it is. Now, we're going to have to use that again because we have to find the magnitude of this vector too. So I'm going to store that one as my x. So negative 15.833. And I also have that stored as my x. Now I'm going 3b minus 2d. 48.920.
921.
921? Yep. And I'm gonna store that as y. 48.921. The magnitude of that now for me on my calculator is going to be the square root of x squared plus y squared. Square the horizontal, square the vertical, add them together, take the square root. Okay? Because I stored those two as x and y, I can come back here to my calculator and I can go square root of x squared plus y squared. And I know that, I forgot to tell you, I know that x and y have values stored on them because they're bold. They're not italic, just regular. Okay? They're bold and they're non-italic. That means I know that there's a value there. And then when I hit enter, I get the magnitude of that vector is 51.419. With me? Okay. I want to show you the angle, finding the angle too. Okay? So if I'm dealing here now with u plus v, oops, hold on, I don't want to do that. If I'm dealing now with u plus v, that would be the vector a plus c, b plus d. Would you agree with that from our original one? Okay? So a plus c is that, and I'm going to store that now as, I'm going to pick two more here. I'm going to go t and u. 5.084. And I stored that as my t. Then I've got b plus d, and I can store that as my u. No, I don't want to use u because u is already in there. I should have picked something different than t. Oh well, I'll go n. I want to get confused with vector u. 7.916. And I stored that as n. Okay? So there's vector u plus v. Found it, have it, stored it. Now, to find the angle, the direction angle, okay? So then that's going to be, which quadrant am I in? I'm in quadrant 1, so my reference angle is my actual direction angle, so I can go right to it. Okay? So this then would be the inverse tangent of n divided by t. So on my calculator, where did that go? There it went. On my calculator, I just have to go trig inverse tangent of n divided by t. And I get 57.289 degrees. Right? 57.289, 57.289. Questions on any of that? Again, using these calculators with that feature, especially next week. Because next week we're going to get into today we're going to get into multiple forces, so we're going to use them again today. But next week we're going to have different kinds of, we're going to add in currents and winds and all that stuff. And so we're going to be adding multiple vectors together. It helps to have those stored, and then you don't have to recalculate them every time, or you don't have to round every time. Okay? All right? You now find me the component form of vector 2v minus 2u. You should have all of that on your calculator, so you should be able to do that one relatively quickly. So this should be the vector 2c minus 2a, comma, 2d minus 2b. Because it's 2v minus 2u. Okay? So that then would become 2c minus 2a is 14.700. And 2d minus 2b is negative 35.970. Yes? Cool. And trust me, I've been doing this for years. I was resistant to the TI Inspire when it first came out too. But then I'm like, oh wait, I can store 26 different variables in there. So I can do my work once and then I don't have to do my work again. I can just have it, boom, 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 done. Yes, please. Okay? Alright? So let's talk multiple forces. So if you always used to have, now I probably won't be able to find it. That's only half of a ball.
Half of a ball.
We must have gotten rid of them. Oh, we'll have to use a baseball. We always had a couple of volleyballs too. Back when I coached volleyball unit circle project, there's a lot of volleyballs, people trying to get extra points by tugging at the heartstrings. Okay? So if I have a ball, okay, and just put the ball down there, I know it's not very big and you can't really see it. Come here for a second. Good thing to get trees up. Okay? Right? Push against the wall. Yep, right now. Okay? Which one of us is pushing harder? Okay? Now, so if the ball goes, keep pushing. Keep pushing. If the ball goes this way, who's pushing harder? She is. If the ball goes this way, me. Okay? Here.
Well,
We gotta get 3 people around this small ball, I know. Okay? Alright, ready? Okay, get in there, get in there. Okay? Who's pushing harder? Me. Okay? So it depends on where the more force is, depends on which direction it's gonna go. Thanks, guys. Okay? Right? With me? Okay? So if I have multiple forces, which would mean that I would have like a force acting this way on that soccer ball, right? And then I could have a force acting, oops, I went the wrong way. That way on the soccer ball. Which way is that soccer ball going to end up going? Probably down this way, right? Because the blue force is bigger than the other one, right? Okay. And then if I had another force, acting on it, it would probably level out a little bit more. It would probably come out in this direction a little bit more, right? Okay. Whoop. Whoop. Right? Okay. So the nice thing about multiple forces is it's just straight up trig. Okay? Because it's not navigation. It's just forces. Okay? Alright? So let's do a multiple force type problem. I don't think I got one down here. Nope, I don't. So a force of 50 pounds acts on an object at an angle of 45 degrees. Now we're going 2-dimensional movement here. Okay? We're not going 3-dimensional movement because that would be a whole nother realm of hurt. Okay? Okay? So a 50-pound object or 50-pound force acts on an object at an angle of 45 degrees. A second force of 75 pounds acts on the object at an angle of negative 60 degrees. find the direction and magnitude of the resultant force. Okay? So, we've got force number 1. Here is force number 1. What do you want to call that vector? We're going to change it over into a vector. You got 26 to choose from. A. Okay, so we'll call this vector A. All right. What's the magnitude of vector A? 50 is my magnitude. What's my direction angle? 45. So that means then we're going to have 50 cosine of 45 degrees, 50 sine of 45 degrees. Right? Okay. Force B is there, yes. Do we like an angle of negative 60 degrees? What do we like instead? Positive 300. Could I still use negative 60 degrees? Yeah, because negative 60 degrees is the same as 300 degrees. So it doesn't matter. You don't even need to change over that one. 75. Okay. Here's where the calculator comes in. Now, this is what I recommend too. Okay? So we're starting a new problem now, correct? We finished our last one. We have a ton of stuff stored on our calculator right now. Okay? So to alleviate that, what we're going to do is we are going to tap the on key and we're going to start a new document. Because what that does is by not saving it, it erases all of those saved values for you. Okay? So you don't have to be confused anymore. You get a fresh, clean slate. You can start a brand new document every problem. Okay? And you got a fresh, clean slate. Okay? So my first one was 50 cosine of 45 degrees. Now, I don't think yours is the CAS. Yours are just CX's, right? So yeah, okay, I won't even confuse you with showing it to you the exact way. Mine would give it to me the exact way as 25 square roots of 2. And I can store 25 square roots of 2, and it'll use it in decimal form or in radical form, whichever one I want. Okay? So that's 35.355. I'm going to store that as my A. B is going to be the same thing. Okay. To make it easy, I'm still going to store that in there. And you can, if you close off that set of parentheses, you can go directly to the storing of it. Okay? You can go directly to storing it as B if you close off the parentheses. Okay? Then we've got 75 cosine of 300. Store that as C, 37.5. Then we've got 75 sine of 300. Store that as D. Negative 64.952. Okay. Which one do you want to find first? Magnitude or direction? Well, actually, we have to, what do we have to find first? What is the resultant vector going to be? Vector, say louder. Vector A plus vector B. Yep, okay. So we need to find here now vector A plus B because that's going to be my resultant vector. So that's going to be vector A plus C, B plus D, $72.855. And I got that stored as my X. B plus D, and I'm going to store that one as my Y. Negative 29.597. So now I have the magnitude of A plus B is going to be the square root of, on my calculator, x squared plus y squared. $78.63. Yep, 638. I just had to double check it. 638. What did I say? 78? 78, 638. And what is that? What's that label? Pounds. Yep. Force is labeled in pounds. So I have to label my answer. The magnitude is 78.638 pounds of force. Now I need to find the reference, or my angle. Which quadrant am I in? I'm in quadrant 4. So that means I'm going to have to find my reference angle first. Now, here is the downfall with the calculators. Because one of them is negative, right? And we need to drop that negative. So when I go to type it into my calculator, I'm going to go inverse tangent. Because my y is negative already, I'm going to have to go negative y to get rid of the negative on the y already. Divided by x. That's the downfall of that. You've got to make that fraction be positive, so we need to multiply it by -1. So I get an angle or reference angle there of 22.109. But you said this was in quadrant 4. So quadrant 4 angles, actual theta is how much? 360 minus my reference angle. Okay, so on my calculator, I can go 360 minus, and the answer is control negative. So it'll subtract off that one, kind of like your other, the handheld one, the other basic ones do. Okay, and so I get 377 or 337.891 degrees. Questions on that? Okay. Be honest, and I, truthfully, I don't care. Okay, I honestly don't care. Does using our calculators make this go a little bit easier for you? Being able to store all of these values. Okay, all right? So just so you know, that option is there. If you don't like it, you by no means have to use it. But I'm just showing you how we make our answer keys. So, and we're kind of sticky. Like I only give 1/1000th of a difference here. Okay? So like I would accept in here 78.637 and 78.639. After that, it's wrong. Okay? And that can be made up if you round very early, and especially if you don't round to very many decimal points. This way, this method, you don't have to round until the very end. It gives you the rounded answer. Okay? All right? Try that one. So let's go vector P is at a magnitude of 70 and a direction angle of negative 30. If you use 330 degrees there, that's fine too. Same thing. Okay. Let's go vector A is 40 and 45. And vector G, just making up letters here. 60 okay. 70, negative 30, 40 and 45, 60 and 135. Okay. Okay. 60.622. Oh, negative 35. Wait, tap the brakes. 70. It's 35. Yes. Okay. Twenty-eight, 4.
Yeah. It's easy. It is. It's easy to just it's just a little. That makes sense. I just don't like it.
Forty-two, 6. Negative first. Okay. So my resultant vector is going to be vector P plus A plus G. Okay. And then, so that's going to be, so for me, it's A plus B plus C. I'm going to store as X. And H plus I plus J, I'm going to store as Y. So we've got 46, I should just write this down. 46, 480. And 35, 711. Let's keep it math related. $46.480 and 35.711. Okay. So now we need to find the magnitude. That's going to be my resultant force, or the poundage, I should say. So that's going to be I stored them as X and Y. £58.614. Do we agree with that? I'm in quadrant number 1. So therefore my reference angle is my actual theta. So this would just be the inverse tangent of y over x. $37.535.
Linz,
What's up?
on the quiz, do you want us to write out like the full like decimal, like all 5 places, or can we use like the A plus C plus E?
So that's up to you. Yep. But your answer would be, so like if this was if I wanted to know the vector as your answer, I would want this as your rounded to 3.
Okay, sounds good.
Okay? All right? Good job.